Customer Case 1. Problem introduction.
Our long-term customer from aerospace and system industry struggled for more than a year with cracks appearance at specific welds of his large electronic structure. The cracks appeared after performing vibration testing, which simulated off-road transportation in compliance with the industry standards. This large electronic structure consisted of many complex CNC machined parts, welded parts, servo-axis sub-assemblies, many electronic units attached to structural parts, vibration dampers between the base and moving structure, and various types of connecting screws and other fastener types.
Creating FEA simulation model.
After understanding of customers' specific design and requirements, the detailed expert-level FEA model of the electronic structure was created for performing virtual testing of the electronic structure. The FEA model included all structural parts from the assembly structure. Special attention was made to create high-quality FE mesh for all structural parts, especially for thin-shelled, in order to represent their mass and stiffness correctly. Servo axes were modeled and integrated by use of specific bearing FEA models with appropriate bearing stiffness, radial, axial and tilt corresponding to the preloaded bearings taken from bearings data sheet.
Creating FEA simulation model.
The dampers were modeled and integrated by use of specific FEA damper model, based on springs and dash pots, where their damping ratio was calculated, according to dampers' transmissibility from dampers data sheet. Inter-part connections were realized by the specific fasteners model, which represents fastener stiffness and allows to get fasteners load output data for fasteners hand calculation, according to industry standard. Finally, all components of this large assembly was integrated and tested to assure FEA model integrity and were ready for FEA simulation.
FEA simulation and problem identification.
After FEA model of the assembly structure was complete, we advanced to FEA simulation stage. The first stage of our FEA expertise project was performed to confirm cracks appearance by virtual testing, which simulated off-road transportation, the same loads, as in physical testing, according to industry standard. Results examination show that third natural frequency of this assembly structure was located in the vicinity of the vibration excitation frequency. Very low structural damping increased vibration level. Also we found that third modal deflection shape matched the same direction as a vibration excitation. It means that all structure resonance conditions has been met.
Problem solving.
After understanding the root cause of his design problem, we discussed performing updated design solution at the meeting with customer. The updated design idea was to perform shifting of third natural frequency as far as possible from excitation frequency, by adding stiffening ribs at the specific area of the structure. Based on the last design idea, we tested several design configurations, in constant interaction and collaboration with the customer, until the last design configuration satisfied all design safety requirements. The third modal frequency was increased to 6 Hz and it was good enough to avoid resonance development risk.
Problem solving.
FEA results examination of last design configuration show low fatigue stresses at welds area, where cracks were developed in the basic design configuration, due to developed structure resonance. Maximum stress level was far below the material fatigue strength and therefore, no risk of cracking again existed. After the last design configuration was produced, the customer confirmed low vibration level at structure physical testing, due to absence of resonance conditions. The design problem was obviously solved and the detailed final technical report was written and sent to the customer.
Studied lessons.
This customer studied one important lesson: the true benefits from our predictive FEA expertise is when it performed at early design and not after prototype production and testing and design failure.
As a result, his next system structure design projects were performed in collaboration with our FEA expertise from early conceptual design, and design iterations were performed always before making decision to produce a prototype.
Obtained benefits.
This customer benefited from our FEA expertise, i.e., 1. Got visual understanding of his design problem. 2. Found design ideas that solved the design problem. 3. Checked each design idea and found the best one. 4. Studied lesson that real profit from our FEA expertise is at early product design. 5. Reached near completeness of his mechanical design.
Testimonial. Project manager, employed our FEA expertise for last 6 years.
Performing FEA prediction expertise while designing brings us to near perfection in terms of strength and resistance to vibration and shock, meeting a schedule that is often very important in our today's industry.
End of customer case 1.